Welcome to video S9. This one's just going to be about graphs. So reading key things from a graph. This is important because we'll be making graphs, we'll be reading graphs. So let's get comfortable with the terminology and then pulling information off these graphs. So things we're going to look for. We know intercepts are where a graph crosses the axis. We can cross the x and the y axes. Domain, what inputs are allowed. Range, what possible outputs are there. The max or min is going to be the highest or lowest output value on the graph. Increasing, decreasing is going to be what's happening as x moves or input value moves from left to right. And then asymptotes are going to be lines that a graph approaches, probably does not hit, especially in the case of vertical asymptotes, it won't hit. Horizontal and behavior, we'll talk more about that next year. So let's just start with a line, just the boring old line. So example one, here's a graph. Now, these questions are giving me the function. You often won't actually know the function, right? But this is nice to kind of confirm for ourselves. So let's take a look through what do we see. So x-intercept, where do I cross the x-axis? Right here. Now no, x-intercept, we've talked about this in previous videos. This is a coordinate point, so 4, 0. Y-intercept, where do we cross the y-axis? Right there. So that would, again, coordinate point would be 0, 2. Domain, what are the allowable x's? Well, these graphs aren't going to have them, but like often in textbooks we do the same thing. When the lines go right to the edge of the graph, there's implied arrows there. So here I'm saying on the left and the right, there's no stop signs, right? So I'm saying x can be whatever we want. I could say xer or an interval notation. So x can be anything from negative infinity to positive infinity. It's all good. Range is going to be the exact same thing, right? So same thing. We're going to go up this way, down this way. So y is also just open season, like whatever. It can be anything. There's no stop signs on it. And finally, increasing, decreasing. This doesn't have to be constant, but for a line it is because there's no turning points, right? This thing never changes direction. So left to right, as I read left to right, what's my function doing? Well, it's dropping. So I am a decreasing function. So I am decreasing. And that is it. So you kind of see, like think about how you did that, name those features. Then we'll try one for you. Okay, so here's what for you to try. So you can see the line there. So same idea. State the intercepts, domain, range, and where it is increasing or decreasing. Pause the video and we'll come back to discuss this one. And there's the answer. So again, pretty similar. Again, just a line. So I'm going to move on to a quadratic. So what's happening with a quadratic? So here is a quadratic function. So you can see we have an upward facing quadratic. I'm looking at this. I can see the vertex, which is really important for us. So 1, -4. So I'm going to fill this one out. So vertex I can see is 1, -4. Got it. Axis of symmetry. I know that's the x part of the vertex. That's just that line goes through here. Note that it is a vertical line, so it's an equation. So x equals 1. The max or the min, it does happen at the vertex. So what I'll say here is it's a minimum. So I'll say it's a min at, I'll say min of y equals -4. If it said minimum point, I would state that point, which would be 1, -4. All right, so just kind of like onward another question. X-intercepts, I could see -1, +3. Again, those are coordinate pairs. Y-intercept, I can see -3, so 0, -3 because it's a y coordinate there. Domain, again, I have an unrestricted domain. So it's just going to be x, can be anything from -infinity up to infinity. Range, well, I have minimum value, right? So my range here is going to be no lower than -4. So -4 up to infinity. And notice that minimum -4 is included. Finally, increasing, decreasing. This is a little different because I have a turning point. So coming into my turning point, as I go left to right, I'm decreasing into it. So I'm decreasing up to 1. So decreasing for any x's up to 1. I'm increasing for any x's out of 1. So I'm increasing for any x's from 1 up to infinity. You might be asking, what about at 1? Well, I'm not increasing or I'm not decreasing there, so it's actually a stationary point, which you'll come back to a lot more for in Calculus 12. So that's I do example 2. So I'm going to pull one up for you to try. So here's yours. So another quadratic. Take a shot at this one, and then we'll kind of end with a more interesting example. So pause the video, try this one, we'll come back together. And there are your answers. So pretty similar question. You can see we're opening down, so that vertex becomes a maximum, flips the range over, and our increase and decrease in intervals switch. Okay, so one more example of each. First one is for me to do. So here's this question. So this one said we got a reciprocal function. So we got g is the reciprocal of f, and f is a quadratic. So let's take a look at this one. So first of all, what are zeros of f? So f, I can see is x squared minus 1, or I could kind of read this backwards, but because I have the function, I'll say, well, x squared minus 1 equals 0. I know it's x plus 1, x minus 1 equals 0. So x is plus or minus 1. So my zeros are x equals plus or minus 1. Now those values become these asymptotes because g is 1 over f, right? So g of x is going to be 1 over x squared minus 1. So here I can't have that denominator be 0. So my vertical asymptotes are going to be x equals plus or minus 1. And those are those vertical lines. Horizontal asymptote. In pre-cal 11, this is going to be y equals 0. We can see that because as x gets large or very negative, this bottom is going to get huge and it's going to be 1 over a really big number. So horizontal asymptote will kind of automatically be y is 0. Now that's just the end behavior. So as we get big, what's happened to our graph? Our domain, if we look at x's, basically everything's okay except for vertical asymptotes. So our vertical asymptotes are x cannot be negative 1 or 1. So our domain is just going to remove those numbers. So we're going to say, so x is an element of, so we can go negative infinity to negative 1, or negative 1 to 1, or 1 to infinity. Or you could do set notation and say x is a real number, x can't be plus or minus 1. That's also fine. So, or x is an element of the reals, x is not plus or minus 1. Done. Range. This is a little bit of a trickier question. So if I look at the range, I can see, I'm going to get another color here. All my y's here are good, so except for 0. So I'm going to say basically, I'll just write it informally. Y is bigger than 0 kind of sums that part up. Now down here though, what is that? Because I can see I'm going to go down. So I can see down here, on the bottom half of the graph, I'm going to have be y is less than something. But what is that number? Now for that, I need to go back and think about what the vertex was of f. So f, x squared minus 1, this thing is going to have a vertex at negative 1. So vertex here is 0, negative 1. Now if I flip that point upside down, that's also going to be negative 1. So I again get a vertex at negative 1. So what that means is y is less than negative 1. What that tells me is the graph doesn't exist at all between negative 1 and 0. So my overall range here is going to be y is anything up to negative 1 or bigger than 0. But I have that big gap between negative 1 and 0. And actually negative 1, sorry, negative 1 is included. So there should be a square bracket there. If I look at x-intercepts, no, there are no x-intercepts, right? Because I can't cross the graph because of the horizontal asymptote on these questions. That will change next year, but for now, I can't cross it. And then finally, y-intercept, well, I already have it 0, negative 1. So 0, negative 1. So that was a much more involved question. You can see a lot of those features still hold up. So last one of the day here, I have one for you. Here is your question. So I'll kind of pull it all up there. You do 3, try to get all the information off of that graph. So pause the video, try it, and we'll take a look. Okay, going over the last one here. So a little easier because it's sort of reciprocal of a line. It's a pretty similar idea. The 0 of f becomes the vertical asymptote of g because the denominator can't be 0. horizontal asymptote is going to stay at 0. Our domain and range, we can write those two different ways. So either I can do interval notation, which is a little more tedious, or a step builder notation, just remove the value I'm not going to hit. In this case, notice the range doesn't have that vertex, so I'm just going to remove the horizontal asymptote of 0. Because I removed that, there's no x-intercept. And y-intercept, no, I couldn't read that from my graph. So what I'm going to do is, well, I can easily find the y-intercept of my original line, plug in 0 and I get 2 back. And then I know my g function is 1 over f. So 1 over 2 is my y-intercept. And that's it. Quick checklist here to finish this one off. So be able to name those features, find them on graphs, write them with the correct notation, right? So remember when to write a point, when to write an equation, and then using proper interval set notation. Remember, domain is your x's, range is your y's. And then for g of x is 1 over f of x. Note the relation between g and f as you kind of move back and forth. And that's it. Thanks for watching.